right, so section 7.3 is what we're doing today. I need to actually get to 7.3. 7.3 is on solving equations using quadratic techniques. All right, so basically all of chapter 6 was on quadratic equations. Quadratic equations looked like something like ax squared plus bx plus c equals 0. All right, we know how to solve quadratic equations. We learned how to factor them. We learned how to complete the square. We learned how to use the quadratic formula. We've done all kinds of things with quadratic equations. Okay, but we haven't done much with things where there's like x to the 6th, x to the 4th. So the key to this section is we're going to try to get them to look like our quadratic equations so we can solve. Okay, so we're going to use something called W substitutions. So we're going to use W's to rewrite it so that we have AW squared plus BW plus C equals 0. Okay, so we're going to get it to be in the quadratic form. All right, so number 1, we have 2x to the 6th plus x to the 3rd plus 9. And I want to write it so that it's 2w squared plus w plus 9. In order to do that, so I'm going to erase that, what do I need to let w equal? Yeah, do you guys see if w is equal to x to the 3rd? Then if I squared both sides, so w squared, if I had x to the 3rd squared, that's x to the 6th. That's what I want. Because now x to the 6th is my w squared, x to the 3rd is my w. So I have 2w squared plus w plus 9. Okay, so now it's a quadratic expression. Now the next one won't have a middle term, but you can get it to be w squared. So if I wanted it to be w squared, I'm going to let w equal x to the 5th. Because then w squared is x to the 10th. So this would be 7w squared plus 6. Yeah, Monica?
Why is it like capital?
It doesn't have to. It could be a U, it could be W, it could be capital, not capital. Just the way that I teach it is with the capital W. Give me a little one if you want. All right, so number 3. So I have x to the 4th plus 2x to the 3rd minus 1. This one cannot be written in that form. Because if you think about it, so you don't have to write this, but if you let w equal x to the 3rd, w squared would be x to the 6th. But this isn't w squared. X to the 4th isn't x to the 6th. Okay, so then you think, well, what if w was x to the 2nd? Then that means w squared would be x to the 4th, but then x to the 3rd isn't w. So see how it's not going to get into that quadratic form? So this one is not possible. So we might have a w squared, but then we wouldn't have a w. Might have a w, but then not w squared. All right, this last one can be, though. So we're going to let w equal something so that when I square both sides, I get the other thing. So I'm going to let w equal my x to the 1/3. Notice how I didn't put a number out front or anything. It's just x to the 1/3. So when you square both sides, think about it. If you have x to the 1/3 and you square both sides, you multiply your powers. So it's x to the 2/3, right? So w squared is x to the 2/3. And that's exactly what we want, because now this is w squared plus 2w minus 4. So it's in that quadratic form. Does it make sense how we do the setup? Okay, now these aren't equations, so we didn't have to solve for anything. We're actually going to try to solve some different things. Okay, now the first couple of equations with the x to the 4ths are really easy to solve without using this w substitution. So I'm going to show you very quickly, you don't have to write this, how you could solve without the w substitution. So if I factored, remember if I have x to the 4th, that's just x squared times x squared. I would need -1 and -4 to multiply to be +4, and the outer and inner combined to be 5. And then those would actually factor down further, right? Each one. So I would have 4 solutions. What would my 4 solutions be? Ryan.
X equals plus or minus 2, and x equals plus or minus 1.
Yep, 2, -2, 1, -1. Those would be my 4 solutions. Very easy to do. I mean, that was really quick. But we want to learn this W substitution with these so that it's going to be useful for 3, which looks really weird, and 4, which right now is red X, but I will show you what 4 looks like. Sometimes my equations don't save. I don't know why. All right, so this is going to be a little bit more complicated, but it's going to show you the method that we're going to use for these more complicated problems. All right, so what I'm going to do is I'm going to let W equal x to the second. So that way if I square both sides, W squared is x to the 4th. So that means my new equation is W squared minus 5W plus 4 equals 0. And I can solve it. So I factor just like normal. So I get W minus 4 and W minus 1. And I solve for W. So I get W equals 4 and W equals 1. But my original problem didn't have W's in it. It had X's. So I want X equals in the end. I have W equals. So we resubstitute. So W was x squared. So since I have W equals 4, that means x squared equals 4. And x squared equals 1. Then I solve both of those equations. So if I have x squared equals 4, how do I get x by itself? And whenever I take the square root, I write plus or minus, right? So I get x equals plus or minus 2, and x equals plus or minus 1. And those are the exact same answers we had when we did it the easier way, right? I know. You're learning the process because it's going to be very useful on ones like number 6 that we have, right? Learning how to do this. Okay, so go ahead and try number 2. So try number 2 on your own. I'll come around and check. All right, here we go. All right, so did you guys get the answer?
Yes.
What'd you get?
X equals plus or minus 5 and x equals plus or minus 2.
That's right, plus or minus 5 and plus or minus 2. So how many of you guys got that answer?
Oh, right here.
Good. A lot of you, not all of you. So let's go through. So I would let W equal x squared. So that means W squared is x to the 4th. So I want to replace with all W's. So I'm going to have W squared minus 29 W plus 100 equals 0. So when I factor, I have W minus 25, W minus 4. That way they multiply to be positive 100, add to be negative 29. So I get W equals 25 and W equals 4. W is the same as x squared. So I replace my W with x squared. So I get x squared equals 25 and x squared equals 4. When I solve for x, I take the square root of both sides, so I get x equals plus or minus 5 and x equals plus or minus 2. Those are your two answers. Okay, makes sense? All right, so let's get to the harder ones. So we know how to do x to the 4th. Let's do x to the 1/2. All right, so I have x to the 1/2 minus x to the 1/4 minus 6 equals 0. So what do you guys think I'm going to let W equal?
X to the 1/4.
X to the 1/4, right? It's always the one with the smallest power. So W equals x to the 1/4. That means W squared would be whatever x to the 1/4 is squared. X to the 1/2, right? You multiply your powers, which is exactly what we want. We want to have that W squared. So I have W squared minus W minus 6 equals 0. I'm ready to factor. So I have W minus 3, W plus 2. Right, they multiply to be negative 6, outer and inner combined to be negative 1. So I get W equals 3, W equals negative 2. If you run out of room, you can always use your additional notes area. Don't freak out. Yep, we want x equals in the end, so what do I do now?
You plug it in for x to the 1/4.
Yeah, x to the 1/4 was what w was, so x to the 1/4 equals 3, x to the 1/4 equals negative 2. So Melvin, how do I get rid of a 1/4 power?
Wait, where are you? Sorry. To the 4th.
Yeah, you raise it to the 4th, right? Shh, guys. So see how if you raise it to the 1/4, you multiply your powers. 1/4 times 4 is 1. So you have x to the 1 now, which is what you want. You want x. 3 to the 4th is 3 times 3 times 3 times 3, which is 9 times 9. Good job, you guys are speedy. 81. All right, the next one. So if I have x to the 1/4 and I raise it to the 4th,
16.
I have negative 2 to the 4th, which is 16. All right, I will tell you one of these does not work. Which is your guess?
16.
16 does not work. You can go back and check. If you check in your original, you have 16 to the 1/2, which is 4, minus 16 to the 1/4. 16 to the 1/4, remember that means the 4th root of 16. So you're saying, what do you multiply by itself 4 times to get 16? 2. So minus 2, minus 6, that's 2 minus 6, that's negative 4. It's not equal to 0, like it's supposed to, so that does not work. If you check 81, 81 does work. So 81 is 81 to the 1/2, which is 9, minus 81 to the 1/4. What's 81 to the 1/4? 3 minus 6, that does equal 0. So 81 works. All right, I knew from this step right here that that was not going to work. How did I know from that step right there that it was negative? What do you mean by that?
I don't know.
So Matt says it's negative.
But he doesn't know.
It was an observation. Yes.
Because if you you can't do anything. I know how it is. It's hard to say it.
You're not going to multiply something by itself 4 times and get well, I don't know. Okay, so the easiest way to think of it, guys, do you guys remember what's called principal roots? So do you remember, if you have the square root of 81 already there in your problem, square root of 81 plus x equals 0, what number is that? 9. It is not plus or minus 9. It was already in your problem, so it's already using the sign which is in front of it, which is plus. Okay? When you have x to the 1/4, that's saying x with a 4th root. That 4th root is already there. There's no sign in front of it, so we assume it's what we call the principal root. It's a plus. So I have the 4th root of something with a plus out front equals negative 2. That can't happen. You have a principal root equals a negative number. It will not happen. So if you get an even root equaling a negative number, you can know from that point right there that it's not going to work. So you can just cross that part out. It won't work. What if I had x to the 1/3 equals negative 2? Can that work? Yeah, it's an odd root. Odd roots can equal negative numbers. Okay, so only if it's an even root. But if you forget that rule, just go ahead and finish out the problem, go back and check. Not a big deal. All right, so number 4. So my equations get removed sometimes when I save because my files are so large. I mean, I do have 200 and something pages on your 205 pages on your notes, 206 pages, yeah. So sometimes my file's too big and it gets rid of my equation. So anyway, your equation is x to the 1/4. Wait, x to the 1/2. I lied. Minus 3x to the 1/3 equals 3x to the 1/6 minus 9. Okay, so that's our equation. All right, so first things first, I would get everything on one side of the equation, set it equal to 0. So I'm going to have x to the 1/2 minus 3x to the 1/3 minus 3x to the 1/6, add the 9, equals 0. And I want to make sure it's in descending order so that the powers go down. Do they go down? Yeah. If you weren't sure, get common denominators. This might help anyway for you to get common denominators. So x to the 3/6 minus 3x to the 2/3, or 2/6 minus 3x to the 1/6 plus 9 equals 0.
9 go first though, because the 9 has an exponent of 1.
9 has an exponent of 0. It's x to the 0.
No, but I mean on the 9 itself.
Nope. You got to think about x's.
Okay.
You guys get over there? All right. So what do you think your w is going to be? Yeah. Do you guys see that? So let w equal x to the 1/6. Now how am I going to get an x to the 2/6 out of that? W squared. How am I going to get an x to the 3/6 out of that? W cubed, right? So that means that I have w cubed, that was x to the 3/6, minus 3w squared, that was the x to the 2/6, minus 3w plus 9 equals 0. So ignore all that stuff above. Do you know how to solve something like that? Yes, you do. Factor by grouping, yes.
Bam.
Matt said it first. I heard him. Factor by grouping. Pull out what they have in common, which is w squared. You have w minus 3 left. You know you want to have w minus 3 left. So think about what you need to pull out. Yeah, negative 3. So now you have the w minus 3 that you can pull all the way to the front, and you have w squared minus 3 left. A lot of you guys will freak out at this point and say, I cannot factor w squared minus 3. But that's okay. You can still set it equal to 0 and solve. So you have w minus 3 equals 0. W squared minus 3 equals 0. So you get w equals 3. W squared equals 3. So w equals plus or minus square root of 3. Okay. Almost done. You need to solve for x though, right? Okay, so x was x to the 1/6 was w. So x to the 1/6 equals 3. X to the 1/6 equals, you can write plus or minus square root of 3. Now I went ahead and left it as plus or minus because in order to get rid of a 1/6 power, what do I need to do to both sides? Raise it to what power?
6.
Yeah. Right? See how if you raise it to the 6th, then this becomes x to the first power. So if I'm raising my positive square root of 3 to the 6th, that's the same as raising my negative square root of 3 to the 6th, right? A negative 6 times is positive. A positive 6 times is positive. You get the same answer out. So what is square root of 3 to the 6th?
729.
That's the other one.
Oh.
Brian just told us this one, 729, if you raise the first one to the 6th. So what was the other one?
27.
Yeah, 27. So if you needed to see it, square root of 3 times square root of 3, don't write this if you don't need to. You have 3 times 3 times 3. It's 27. So you get x equals 27. Okay, you can check both. Both will work. So 27 and 729 are your two answers. All right, that was a hard one. Next page. Okay, this one is x minus 3 square root of x plus 4 equals 0. Oh wait, I lied, minus 4. See, this is why I write it on my notes. Minus 4 equals, yeah,
On the last one,
yeah.
like if you on the x to the 1/6 equals plus or minus square root of 3, if those were like two different ones, and if it was like if you got two different answers, then x to the 1/6 equals negative square root of 3. That one wouldn't be right?
Yes, but I see what you're saying. So if it was, yeah, so 27 is a solution. It works because of the square root of 3. Do you guys see what she's saying? The negative answer wouldn't work because you'd have x to the 1/6, an even root equals a negative number. But that answer works in the end because of the positive square root of 3. You're not going to get them equaling two separate numbers. Right. When the w squared equals 3. You'll always get the same number.
And if it's like a plus or minus square root, then it should work.
Yeah, it will work out. All right, next up. So x minus 3 square root of x minus 4 equals 0. So what do you think w is? Square root of x, right? That way w squared is square root of x squared, which is x. So we have w squared minus 3w minus 4 equals 0. Okay, factor. Set each piece equal to 0, so w equals 4, w equals negative 1. So w is the same as square root of x, so you have square root of x equals 4 and square root of x equals negative 1. A lot of you guys are going to be tempted to say the answer is plus or minus 2.
But it's not.
It's not.
Because it's 16.
It is 16. Good job. Because you have to square both sides, right? So x equals 16. The other one is x equals 1, but I know that that's not going to work anyway. Why do I know it's not going to work? Yeah, because you have the positive square root of x equals a negative 1. Can't happen. You could go back and check. If you went back and checked, you'd have 1 minus 3 minus 4 does not equal 0. If you check the 16, you have 16 minus 3 times 4 minus 4. That's 16 minus 12 is 4 minus 4. That does equal 0. So 16 works. Okay, and then the last one we're going to do today is kind of a doozy. Think we can handle it. All right, so back when I taught at IU, I always taught a class called Pre-Calculus there, MO25. And for some, I mean, we did W substitutions in there. That's where I got to use the W. That's where I started using the W. That's what Monica was asking. And in this class, they would do some pretty tough ones. They did ones like number 6. And for some reason, they just love these problems. And they always had like 5 of these on the midterm. So your book doesn't go in as much detail as number 6. It goes to like what number 5 looked like. But I decided that we would go ahead and do number 6 in case you do go to IU someday, and you will have these mastered. You're never going to go to IU?
What about Purdue?
You say that now. You say that now.
What about Purdue?
All right, so here we go.
Let's try this.
Stanford.
Stanford. I want Stanford.
All right, so what do we think W is going to be? First of all, I would write it in descending order. Shh, guys. Write it in descending order. So when you look at your powers, you have 5 halves. You need the 3 halves next, and then the 1 half. So you want the 5, 3, and then 1. So I'm going to have x plus 1 to the 5 over 2 minus 5 times x plus 1 to the 3 over 2 plus 6 times x plus 1 to the 1 half equals 0. So now it's in descending order. What do you think W is? X plus 1 to the 1 half, right. So you knew it had the x plus 1 because they all have the x plus 1 in common. The 1 half was the other part. All right, now if you think about it, you can see how the other ones are related. How do I get x plus 1 to the 3 over 2? What do I need to raise W to? The third, right? I'm writing the third, it's not writing. All right, and if you want to get x plus 1 to the 5 over 2, you have to raise it to the 5th. Now the thing people get confused on is for some reason they still want to write x plus 1, only they'll write w plus 1 to the 5 or something weird. You've gotten rid of this x plus 1. The x plus 1 to the 1 half was w. So if I have x plus 1 to the 5 over 2, that was w to the 5th. So don't make it harder than this. So w to the 5th minus 5 w to the 3rd plus 6w equals 0. This isn't really in the quadratic form because it's not x squared or w squared. But it kind of looks like it. Yeah, you can pull out a common factor, which is W. Alex Nairmore is on top of things today. My right-hand man back here. Now what?
Let's see.
So how about Sam? So Sam Wyatt. Sam Wyatt. What do I do next? I could make this terrible and make you do another substitution, but I'm not going to make you do another substitution.
Pull a negative.
How did you get -6?
Oh, +6. Thank you, Monica. +6. All right, so Sam, how do I factor it?
Is he asleep?
No, Sam Wyatt is in the corner. He's paying
Oh. Sorry.
attention. Sam West, not so much. W squared. And W squared, right? Now here's the tricky part. Some people think it's 2 and 3. Some people think it's 6 and 1.
It's
Still me?
Yep.
-6 and
Brr.
that's wrong.
it's the plus sign, so you have to do.
Right, they need to be the same sign because they multiply to be +6. So that was my fault. I had the typo originally. It is -2 and -3. Okay, so set each piece equal to 0. You get W equals 0. W squared -2 equals 0. W squared -3 equals 0. So W squared equals 2 means W equals plus or minus the square root of 2. Speedy. W squared equals 3 means W equals plus or minus the square root of 3. So you have 5 solutions for W. You have 0, square root of 2, negative square root of 2, square root of 3, negative square root of 3. All right, so now we need x's. So we go back. This is not hard. We have x plus 1. X plus 1 to the 1/2 was what W was, right? So x plus 1 to the 1/2 equals 0. X plus 1 to the 1/2 equals plus or minus the square root of 2. X plus 1 to the 1/2 equals plus or minus the square root of 3. You could have written those out separately if you wanted to. But I noticed it's to the 1/2 power, so I'm going to have to square both sides. So my positive and negative answers are going to give me the same. They're both going to give me a positive answer, right? Okay, first one's pretty easy. Don't just write 0 equals x because you square both sides, so you get 0 equals x plus 1. So x equals -1. The next one, square both sides. So when I square positive square root of 2, what do I get? 2. When I square negative square root of 2, I get 2. So I have x plus 1 equals 2, so x equals 1. And when I try this last one, I get square both sides, I get 3. So x plus 1 equals 3, so x equals 2. Okay, so let's do splitting you down the middle. Maddie Hoover's side of the room, you guys are going to check 1. Who is that in the front? Metzman's side of the room. Eric. Try 2. And see if they work. Now, when I check these in my calculator, here's how I'd put this in. If I was trying 1, I would do 1 plus 1 is 2. So I'd do 2 raised to the parentheses 5 over 2 plus 6 times 2 raised to the parentheses 1 over 2 plus and so on. Okay? So I would check it on my calculator. Do it super fast. After you check the first one, so put it all in one line, hit enter, and then do second enter. It will pull up that equation again so you can edit it.
I think they both work.
You think they both work?
I don't know, I'm just guessing. Like,
Melvin, do they both work?
Actually.
They all work. Alright, check -1. Does -1 work? -1's the easy one. -1 plus 1 is 0. 0, 0. -1 works.
Bye.